Hello and welcome to me, Mr. Russell, going over the non-calculated gap assessment Year 11 Paper 1 sat in September 2020. This was a non-calculated paper and I'm going to go over each question so we can discuss if you made any mistakes and you can see how to correct yourself. Okay, so question one, we have the list of numbers and part I was asking you to find two different numbers that add up to an even number. Well, there are two different ways we can get an even number. We can have an odd plus an odd, which gets us an even, or we can do even plus even, getting us even. So your options was to add any two pairs of odds, such as the 5 and the 15, the 5 and the 125, or the 15 and the 125. Or you could have gone for any pair of evens. So you could have gone with the 30 and the 50, the 50 and the 60, the 60 and the 90, the 90 and the 100, or the 30, 60, etc., etc., etc. Okay. Part II was a multiple of 20. Well, there were two options here. You could have gone for the 60 or the 100. And the reason for that is that both 60 and 100 are in the multiplication tables of 20, which is 20, 40, 60, 80, 100, etc., etc. So both 60 and 100 lie in that. Part III was a factor of 45, or factors divide into numbers without leaving any remainders. So our options there were 15 and 5. And finally, part IV, a cube number. Well, the only cube number in that list is 125 because 5 cubed, meaning 5 times 5 times 5, is the answer 125. Okay. Question 2 was your first bit of algebra, and I'm just going to zoom out ever so slightly so you can see all my paper at once. So here, question 2 was simplify 7x plus 2y minus 3x plus 4y. So what I've done with my working out here is I've underlined my x terms. So I've got 7x minus 3x, giving me an answer of 4x. And I've overlined my y terms, which is 2y plus 4y, give me an answer of 6y. 2 marks there, one for the x term correct, one for the y term correct. Part B was asking you to factorize. When you're asked to factorize, that means you're putting back into brackets. You're trying to find a common factor, so something that you can divide both terms by. In this case, both terms divide by 5. And what we are left with, well, 10x divided by 5 leaves me with 2x. Minus 15 divided by 5 leaves me with minus 3. Okay, part C on that question was asking you to solve. So we have 5p equaling 3p plus 8. Well, in order to keep everything balanced, whatever I do to the left-hand side, I've got to do to the right-hand side. So if I subtract 3p from both sides, it keeps it balanced. I end up with 2p on the left-hand side. I end up with just the 8 on the right. If I then divide both sides by 2, that will give me an answer of p equaling 4. Okay. Right, moving on to the next set of questions. Question 3, this one was expanding. So we have to expand, and that means to multiply everything on the outside by anything on the inside. So my arrows here to indicate two different multiplications. 5 times 2m gives me 10m, and 5 times negative 3 gives me minus 15. Okay. To factorize again, same skill as it was on the other side. I'm looking for something that divides into both 3 and 12. Well, 3 goes into both. What happens when I divide 3n by 3? I just get left with n. And what happens when I divide 12 by 3? I just get left with 4. So I've got 3 brackets n plus 4. Right, question 4. This was the flow diagram one. Well, I've answered it in a flow diagram. There are several different ways of answering this one. The way I thought about this is what's happened to my number, and it says it was a number, so I've just labeled it as n. Well, I said that Stephanie thinks of a positive number and she squares that number. Okay, so she squares it, hence my little 2 up here, and then she adds 7. So I've shown plus 7, and it gives an answer of 43. Well, to work out what her number was, I want to go backwards, meaning I'm doing the inverse operation at each stage. So start with my 43, I subtract 7, give me 36. And then the opposite of squaring is to square root. So square root of 36, give me an answer of 6. Now, the square root of 36 is positive or negative 6, but since a question stated positive number, my answer is just 6. Okay. Question 5, unfortunately printed, and it started down at the bottom. The diagram shows a circle drawn inside a square. Well, that makes no difference because I can see the rest of it on here. We're then asked to work out the area of the shaded section. So I'm thinking that if I've got a square and I subtract the circle from it, then that would leave me with the 4 shaded sections that I've done on my diagram here. So my mathematics is I'm thinking to get the area of the square, well, it's 12 squared, 144. The area of a circle is pi r squared, where I told the radius is 6, so it's pi times 6 squared, give me 36 pi. It wanted my answer in terms of pi, and this is a non-calculator paper, so I will not be using 3.14. I will just leave it in terms of pi. That means that the outer section, all 4 of those, or the section I've shaded over here, will be the 144 minus that 36 pi. But since I'm just wanting one section, which is shaded on the diagram, I need to divide that by 4. So 144 divided by 4 gives me 36. 36 pi divided by 4 leaves me with just 9 pi. So my answer, the number on my answer line is 36 minus 9 pi. Question 6 was asking us to find all the possible values for y. Well, it told us y is an integer, and integers are whole numbers, no decimals. And I'm wanting anything that is greater than -5, but less than or equal to 0. So on a number line, it's all those numbers. We colour in dots if we are equal to, we leave them open if they are just greater than or less than. So all the possible whole numbers between those are -4, -3, -2, -1, and 0. Okay. Part B to that same thing was, again, with the inequalities. We've been asked to solve something. So here I've, again, like previously, I've shown my arrows to show what I'm multiplying. 6 times x gives me 6x. 6 times -2 gives me -12. And that, at this stage, is still greater than 15. Well, to keep everything balanced, just like when it's an equal sign with an inequality, I've got to do the same to both sides. So I added 12 to both sides. 15 or 12 gives me 27. And therefore, if I'm wanting a single x rather than all 6x, I need to divide by 6. So 27 over 6, which simplifies down to 9 over 2. It would be acceptable to write 4.5 as well. Okay, so x is greater than 4.5. Finally, you weren't given much space because most of the space was on the other page. But again, I've used a flow diagram to explain how to rearrange this equation. I thought about it in the terms of P, what's happened to P to give us Q. And I'll do the inverse of that. So P started off by being divided by R. So I've got P, and in my function machine, I've got a divided by R. Sorry about the pen not showing up very well there. That is P divided by R. And then we've added S to it on the end. And that gave us an answer of Q. So going backwards, I've got Q. Instead of adding S, I subtract S. Instead of dividing by R, I multiply by R. And the way I write that, it would be Q subtract S inside my brackets. And then I'm multiplying everything by R, hence the multiplier on the outside. And that just leaves me with P. Okay. On to the next page, which is the other way. There's the working out space. So question 8. We were asked in this one, question 8 and 9, it was all to do with quadratic sequences. We were being asked to find the next term in this sequence. Well, in order to spot what's going on, we need to look at the difference between our sequence, between the sequence numbers at the moment. Well, between 3 and 6, I've got a difference of 3. Between 6 and 11, I've got a 5. Between 11 and 18, I've got 7, etc., etc., etc. Okay? Then, because it's quadratic, I need to look at what I class as my second difference. Now, between 3 and 5 is 2. Between 5 and 7 is 2. In fact, between all of these is 2. That means that I know between 13 and what my next term is going to be increasing by is an extra 2. So 13 plus 2 gives me 15, telling me, therefore, that the difference between 51 and my next term must be 15. Therefore, my next term is 66, because 51 plus 15 gives me 66. Okay? Part B, we're being asked to find the 6th term in a sequence. And for that, we're just going to substitute in the value of 6 into our nth term, which is 2n squared plus 5. Well, following the order of operations, that's 2 multiplied by 6 squared plus 5. Indices is more significant than multiplication or addition. So we square first. 6 squared gives me 36. Multiplication is more significant than addition. So 2 times 36 gives me 72. And then we add 72 and 5 to give me an answer of 77. Okay. Question 9 again was asking us to find. I'll show you here. Find an expression for the nth term of this quadratic sequence, which I've shown on the other side because I've got a lot more space for working out. So my preferred method is, the reason I prefer this method is it suits you far better if you're going on to do advanced level, A level, because you're thinking about it in an algebraic format. So if I start off by writing out my sequence, I've got 1, 3, 7, 13, 21. Then I look at the difference between those. It's going up by 2, then by 4, then by 6, then by 8. And then those are going up by 2, 2, and 2. Now, these equations here are the parts you have to memorize. Your second difference is equal to 2a. Your first difference is equal to 3a plus b. And your first term is equal to a plus b plus c. Okay, those three are need to be known. They are not given anywhere on the formula sheet. Once you've got those, it allows you to find the values of a, b, and c, and we can use those once I show you the answer. So we know that 2a is equal to 2a equals 2. That allows me to get a equal to 1. 3a plus b is equal to 2. So therefore, b is worth -1. And a plus b plus c is equal to 1. And therefore, c is 0. If you're not sure where the b and the c came from, I'll just repeat those. So if I now know that a is worth 1, well, 3 times 1 is 3. 3 plus something gets me 2. That something must have been a -1. A plus b plus c is 1. Well, 1 minus 1. I've made a slight error in my own calculations there. 1 plus -1 is 0. I need an answer of 1. So what I should have done there is written +1. I then use those in this format, an squared plus bn plus c, because this here is your general nth term sequence. N squared minus n, because all these are 1s, minus 1. And I've just realized my own error, which is a good job. I was checking my working out, +1 on the end. And that allows me to also put +1 there on my answer line. Okay. Apologies for the error earlier. Question 10. What we're getting onto here is expanding brackets with surds. Okay. Most of you will probably recognize FOIL. It stands for firsts, outsides, insides, lasts. That just forces us to capture every single part of it and not repeat anything by mistake. Basically, what we're trying to do is take the 1 and multiply it by both terms in the second bracket, and then take the √2 and multiply it by both terms in the second bracket. If I look at my first two terms of my bracket, the 1 multiplied by the 3 gives me 3. The outside parts of my bracket, so the first term by the second term in my second bracket, 1 multiplied by -√2 is -√2. The inside, so the parts closest together, so the second term in my first by the first term in my second, √2 multiplied by 3 gives me 3√2. And finally, √2 multiplied by -√2 just gives me -2. Because if we think about what happens when you multiply roots together, that would be √2 multiplied by √2 giving us √4. We know that the root of 4 is 2, but since there was a negative there, that means it would be the negative of √4, which is -2. We can combine our roots together. I've got -1 lot of √2 plus 3 lots of √2, simplifying down to 2 √2. The 3 and the -2 go together to give us an answer of 1. So my final answer is 2 √2 plus 1. Moving on to question 11. This time we were asked to enlarge a shape by a scale factor of 3. So my preferred method, there are several different methods for this. I'm counting, or it also mentioned from center A. So from center A to get to my closest corner on this, I've gone along 2 and up 1. So because it's a scale factor 3, I then go back to my center and go 3 times as far. So instead of going 2, I'm now going to go 6, because 3 times 2 is 6. Hence, you can see my lines where I'm bouncing there. Instead of going up 1, I'm going to go up 3. So that tells me that this corner here on the enlarged shape is now where I've put that big dot there. Now, my method, I prefer to think about is since I've got my corner right, and then can consider and draw everything else from it. The height of this triangle was originally 2. Well, it now needs to be 3 times as tall as that. So it's now going to be 6 tall. So I've drawn up 6 boxes. The base of my triangle was 3. So it now needs to be 3 times as long as that. So I've drawn 9 across. and I get my 2 new corner points, which I'm allowed to then join up between them. Okay. Question 12, to do with surds, and again, trying to simplify your surd. So we've got here is we've got 5 root 27, which is asking us to simplify in the form n root 3. Well, 27 can be split up into 9 times 3. Okay, the reason I chose 9 and 3 is because I know that 9 itself is a square number. 5 times the root of 9 times the root of 3 is the same as 5 times root 27, because then 9 times 3 gives me that 27. Well, I know that root 9 is worth 3, so I end up replacing 5 root 9 with 5 times 3. Well, 5 times 3 gives me 15. I was asked for an answer in terms of root 3, which conveniently I can't do any more with, so I just get left with 15 root 3 as my answer. When you're asked to rationalize the denominator, I'm just going to change the focus. It looks a bit blurry. There, ever so slightly better. When I rationalize a denominator, I'm trying to get rid of any form of a square root on the bottom of a fraction. The way to do that is to multiply it by the root that you're trying to get rid of. It's over itself, because any number divided by itself is 1, and multiplying a fraction by 1 doesn't change its size. So what we end up with is root 3 multiplied by root 3, which gives us 3, which is the reason is similar to what we looked at earlier on the previous question. And 21 multiplied by root 3 is just 21 root 3. Well, what I end up here with, 21 root 3 over 3, well, the 21 divided by the 3 thankfully simplifies down to just 7. So my final answer is 7 root 3. Okay. Question 13 was asking us to complete the table of the values for y equals 2x plus 3 between 0 and 5. I wrote that at the top of the table on the next one so I can see. For this one, I'm wanting to substitute in the numbers that I don't have yet. So here, let me sec, my computer's just, there we go. I'm wanting to sub in 0 into my equation. So 2 lots of 0 is 0, add 3 gives me 3. The next number I was missing was when x was worth 2. So 2 lots of 2 is 4, plus 3 gives me 7. I repeat for the final 2 by saying 2 times 4 gives me 8, plus 3 gives 11. And I repeat for the last one, give me 13. Or what I can do is, once I'm confident on my gaps, I've got a gap there of 2, gap there of 2, gap there of 2, all because I know it's going up by 2 every time. Okay, so I get my sequence and then asked to repeat this into a graph. Okay, and if I just shuffle that up slightly, what I've done is I've taken this as a pair of coordinates. So 0, 3, 0 along, 3 up. I repeated that for each of these, placed all those in the right place, and then joined it up with a straight line. It says draw a graph. It doesn't say plot points. So the graph itself, that's why it's worth 2 marks down here. Down here is because it says draw a graph. You would only get 1 mark if you plotted your points. You get 2 marks for joining them up, because that's what they've asked you to do. Okay. Question 14. Bear with me. I've just clicked something on my screen and I can't see my own working out. And I'm back. Okay. Question 14 is split over 2 pages. Apologies. In a tin of baked beans, we've been given the weight of the beans to the weight of the tomatoes to the weight of the other ingredients is equal to 3 to 2 to 1 in that ratio. We're being told that 150 grams of tomatoes is in the tin. So I can therefore, what I've underlined is all the parts that are tomatoes. The tomatoes is a middle number in the ratio, which is equal to the 2. And as 150 grams of tomatoes was in the tin, I can then say that only one part will be the 150 divided by 2, give me 75. That means that every part in this ratio is worth 75. The question we are being asked for is saying, work out the weight of the beans. Well, there are 3 parts beans in the tin, so 3 lots of 75 gives me 225. Okay. Question 15. We were asked to add 2 fractions together. Well, these 2 fractions have don't have the same denominator. So our first job is to get a common denominator. We've gone for 20 because it's the lowest common multiple of 5 and 4, and I've kept my fractions equivalent. 2/5 is equivalent to 8/20, because 5 multiplied by 4 gives me 20. So 2 multiplied by 4 gives me 8. 4 multiplied by 5 gets me 20. So 1 multiplied by 5 gets me 5. Once I've got a common denominator, I can then add my numerators together. So 8 plus 5 gives me an answer of 13. 13 over 20 doesn't simplify any further, so that's just my final answer. Part B to that question was asking us to write down the value of 2 to the power of -3. So when we have a power that is negative, that will be the same as doing 1 divided by that same number to the positive. Okay, so that we need to be aware of that, and that's where most people may make errors, is that they will just do 2 to the power of 3, or they'll write that as an answer of -8. It is not -8. We have to do it as 1 over 2 to the power of 3. 2 to the power of 3 is 8, so we end up with an answer of 1 over 8, or if you want to work it out as a decimal, that'd be 0.125. Question 16 was asking us to write, express 56 as a product of its prime factors. Well, 56 is 7 times 8. I've circled the 7 because it's prime. The 8 isn't prime. I can split that up into a 4 and a 2 because 4 times 2 gets me 8. 2 is prime, 4 isn't, so I need to split that one up and I get 2 and a 2. I end up with 3 2's, so I write that as 2 to the power of 3 times by the 7 that is here. Okay, so 2 to the power of 3 times 7. And I wrote that again on my answer line. And finally, the last question was asking us to write x squared plus 2x minus 8 in the form x plus m in brackets squared plus n, where m and n are integers. The skill here is complete the square. So our method here is that we're wanting to get this bracket to get, this equation back to something like this. That would mean I would need to get 2 x's from squaring something, so I would need to therefore split that 2x up into 2 separate brackets, hence I half it, so half of 2 is 1. X plus 1 we'll then put inside the bracket and square it. We would then subtract whatever our number here is, so 1 squared is just 1. We then need to include the number that was by itself here as 8. Minus 1 minus 8 leaves me to -9. So my final answer is x plus 1 in brackets squared subtract 9. Okay, thank you very much. I hope that helped to improve your understanding from the first gap analysis test that we did that was the non-calculator. Thank you very much.